Hi, everybody. Welcome. We got an exciting talk for you, but first, some pro forma stuff. If you're online, you can click to join the discussion there. If you're in the audience, save your questions for after the talk, and then we'll come around and pass the microphone and get the questions. And now, for the actual talk, the one, the only, the amazing, the inimitable Sébastien to talk about efficient containers with Spring Boot 3, Java 21, and CDS.
Thanks, Josh.
Break a leg.
Yeah, welcome everybody. Thanks. So yeah, I'm Sébastien Deleuze. I'm a Spring Framework core committer, and I'm also leading the Spring Efficiency Working Group, which is working with other part of VMware Tanzu division on efficiency. And today we are going to see how we can build efficient containers with Spring Boot 3, Java 21, and CDS. So first, let's ask, why do we care about runtime efficiency? The first reason is cost optimizations. We all want to run our application in a cheaper way. There are millions of Spring applications in the world, hundreds of thousands in your company. At that scale, the technical optimization that we will be doing can translate to big financial benefits. The second reason is sustainability. If we are using smaller machines, we are going to use less CPU, less memory, less energy, which makes our workload more sustainable. And the third reason is optimized containers. We live in a world where likely you will deploy your Spring application using containers, and with the Java virtual machine, dealing with startup time, memory consumption, and warm-up time can be a bit tricky, so we may want to optimize this. So we have different kind of optimization. We can optimize the startup time of our application, and especially on cheap cloud servers, that can be a bit tricky because you have machines that are not very powerful, much less powerful than your local laptop. And when you deploy to production on cheap servers, you could have bad surprise, basically. Memory consumption is also super important because the cost of your cloud hosting is usually related to the amount of memory available. And again, in order to get cheap hosting, you may want to keep the same level of performance, but with less memory consumption. Scalability, it's about throughput, latency, and typically you want to keep the same kind of performance, but again with less resources. And warm-up is more specifically for the JVM, because the JVM, when it starts, is pretty slow, and it needs time to warm up, and then it's super, super fast, like the fastest technology, but it takes time to reach peak performance. So if we take a step back on Spring Boot's main features, we can see quite a focus on efficiency. I mean, Spring Boot 3.0 introduced GraalVM native support in order to compile Spring Boot application to native executables, in order to have small containers, super, super fast startup time, lower memory consumptions. But there is a catch. There is a lot of constraints that GraalVM native images are introducing in order to reach this level of efficiency. So today we are going to see something a bit more easy to leverage for a wide range of projects. I think at Spring I/O at Barcelona, we had a survey, and I think 10% of Spring Boot developers deploy at least one native application in production, which is already pretty good and much more than what I was expected. But I think it will stay in that ballpark, between 5 and 15%, because it's not a good fit for every use case, just for some. And in order to provide this GraalVM native image support, we had to introduce the Spring ahead of time optimizations that we are going to describe a bit more today. Spring Boot 3.2 introduced virtual threads in order to provide better scalability, and Project Crack support, which shares some common goals with CDS, which is another technology that we introduced in Spring Boot 3.3. So CDS stands for Class Data Sharing. It's funny because it is a pretty mature technology that is available in your JVM for quite a few years now, but it has never been used at its full potential. Basically, we were using CDS for optimizing the loading of classes of the JDK, but not for the application itself. So the CDS support that we are going to talk about today is basically involving optimization at both application and JDK level. It involves a training run that will basically start your application, but without contacting remote services. This will create a CDS archive that will then be used for the production run in order to start faster and lower the memory consumption. And Spring Boot 3.3 introduced dedicated support for those training runs. And Spring Boot 3.3 also introduced dedicated support for more optimized class loading with CDS. Spring ahead of time optimization, like I said before, were introduced specifically for GraalVM native image support, and it's mandatory for the native support, but it can also be used optionally with the JVM, okay? So it's another set of optimization that can be combined with the CDS support. It's more at the Spring level, and it's basically going to remove some processing done by Spring during the runtime to move them during the build time in order to achieve faster startup and lower memory consumption. So you will typically, for now, enable it at Maven or Gradle build. So I get a lot of questions from Spring developers asking, okay, there is a lot of technologies, it's cool, I can use Spring Boot with GraalVM, Crack, CDS. Okay, I need to choose what is the best. So it depends, but I think we can begin to have some kind of general guidance, and at least I will share my opinionated point of view. So the GraalVM native support introduces fast startup, like sub 100 millisecond startup, very, very fast, including for big applications, so super good for that. Fast warmup, because you get peak performance available immediately. But there is a catch. The peak throughput is slower than a fully hot JVM, so it's something to keep in mind. You have a smaller memory consumption, it's true, but you have also a price to pay. You have some trade-offs, some drawbacks, some constraints. One of the biggest one is compilation, which is very, very slow, very heavy, and so you need to have big CI/CD machine in order to handle that. The other big issue is compatibility issues, because GraalVM native and regular JVM does not work exactly the same way. It's almost the JVM, but not really. So you need to configure explicitly reflection, proxies, etc., resource access, and there is some very small differences, but that can make a difference. Spring infers most of the native in, so you don't have to take care about that. But for your internal libraries in your companies, or for some use case, you may have to provide additional ints. And when ints are missing, compilation or runtime is broken, so it's not lenient, okay? You have to provide them. Security is very good. So some people from the GraalVM team even claim that it's better than the JVM because reflection has to be configured explicitly, so you can't effectively invoke any crazy methods involved in a CVE. And it's not a regular Java distribution, but you don't really care because you don't have to provide the JVM distribution to run that thing. It's a native executable, like with Go, for example, that you can include in any container without runtimes. The other technology is Crack. Crack stands for Coordinated Restore at Checkpoints. They share basically the same goal with CDS, but I would say Crack is a bit more brutal. So you have very fast startup like native, 100 milliseconds basically for your Spring app. So you say, hey, amazing, 100 milliseconds with the JVM. But in order to get that working, you have to perform a training run, which introduces some constraints. You get optimal peak throughput because that's a regular JVM. You don't get memory consumption because this is a regular JVM. You get the same compilation that you have on a regular JVM, but there are some very big constraints. First constraints, it's a complex lifecycle issue because you are not going to do a real start for your application with Crack on production. You are going to restore your application. That means that you have previously on your CI/CD server perform a first startup, create a checkpoint, and then you do a restore and you continue the startup. And so configuration may not be updated, and that introduces a lot of differences. File handle need to be recreated, socket need to be recreated, and in terms of compatibility, even if Spring Boot 3.2 provides support for Crack, you still require to have a lot of work, and some library may not be supported, and that's a big problem. Second big issue, secret leaking in snapshots. When I say Crack is a bit brutal, it's going to take your running application, create a snapshot file with the memory serialized on disk. So if you have a password for your database in memory, it will end up in the file. And so you can't create really a container with the snapshot file because there is secret in it. And even if that's in a volume, you need to have extra care about the security of that thing. So yeah, it's difficult. And the last point is that there is no support for Windows and Mac because Crack is based on CREU, which is a Linux technology that will only work on Linux. So we'll have to use Docker for Windows and Mac. And there is some additional capabilities that you need to configure for your Linux operating system. So yeah, so it's attractive, but it's difficult to use it for real. CDS has I would say more reasonable improvements, more limited improvement, like 1.x faster startup or 2.x with Spring AOT. But it has also much less constraints. Like training run will come with Project Leyden, which is CDS successor. We are going to talk a bit about that. You get optimal peak throughput. You get a slightly reduced memory consumption, fast compilation. You have just a bit of training run custom configuration to do to avoid early database interaction, but that's it. You don't have security issues. It's already available in your regular JVM, and that's why it's more easily actionable for your project. So if you are asking my advice, and yours may be different, but my advice is JVM with CDS is recommended for better efficiency with few constraints and is, I think, actionable for most of your projects. Native with GraalVM, if you can swallow the pill of native constraints, and if you are interested in super fast build time to scale to zero your application or reduce memory consumption, it's a great option, but you have to accept the constraints. So Spring Boot 3.3 introduces CDS support. And it's introducing that via two big features that I'm going to describe. The first feature is the capability for an executable jar. So executable jar is what you are building with Maven build, Gradle build, Maven package. You get this jar that is including the dependencies, your application, etc. There is already a jar mod tools that is used to extract the various layers of a container. And Spring Boot 3 adds the support for extracting an executable jar to a directory that you will specify. And this file layout is the most efficient way to run your Spring Boot application even without CDS. So even if you don't use CDS, I recommend using that. You don't have to have unzip or any other tools installed on your Docker container because it's just a Java command. So Java is already available. And it's also CDS friendly. I mean, if you are using this layout, you will get optimal CDS performance. If you are using CDS directly with the executable jar, you will get almost no gains. Okay, it's really make a huge difference to use this efficient layout. And this self-extracting mode is pretty handy for that. So let's see a demo. We are going to build our project with Maven. So we get an executable jar. We are going to run this executable jar. We see that we start the application in a bit more than 2.2 seconds. And now we are going to leverage this feature. So we are going to extract this runnable jar into a file layout that you can see here. So we have a lib directory, a smaller jar. The various dependencies are available in the lib directory. We are going to perform a training run using a special Spring Framework parameter and specifying that we want to create that in application.gsa. So this starts the application without contacting all the remote services. We have an application.gsa that is created. This is the CDS archive. And now we are doing the real production run by adding a CDS parameter, mentioning this parameter, and using the efficient layout. And here you can see that without much pain, we are starting the application much, much faster. And there is no catch. I mean, it works. The second feature is something more integrated. So Buildpack is a technology that Spring Boot is using. It's also open source. The technology that Spring Boot is using to package your Spring Boot application with containers. Of course, you can use Docker or other tools, but the built-in support without any configuration is with Buildpacks. And we have added support for CDS in Buildpacks. That means that when you build your application with Buildpacks and you are enabling CDS, Spring Boot and Buildpacks will automatically perform the training run, extract the executable jar into the optimized layout for CDS, ship the CDS archive within your container, so you have a self-contained optimized container. And optionally, you can even activate Spring AOT. This is what we are going to see in a demo very shortly. So we try to keep the right balance between open source and the commercial platform. So we are also providing first-class support for CDS in Tanzu Platform, for Cloud Foundry, and for Kubernetes. And the Tanzu Platform is providing added value that combines very well with Spring Boot efficiency, open source features. We are going to see that a bit more today. So what we are going today is to upgrade and optimize Petclinic in order to enable various optimization, CDS, but also other ones. And if you want to check the various steps I'm going to show today, you can use this QR code or directly use my Petclinic efficient container URL here. You will check the various commits and you will see step by step the upgrade I'm going to do today. So we start from Spring Boot 2.7 Java baseline. We need to upgrade a bit. It's a Maven project. It's a Maven project of Petclinic, the famous samples that we are using. You can see various Java classes. We can see the pom.xml that is using Spring Boot 2.5 and 2.7 and Java 8. Okay? So this is our starting point. We are also using a Docker file in order to create. It's not what I recommend to directly use the executable jar, but here, for the purpose of the demo, we are going to do that because a lot of people are doing that. And we are using Docker file to specify we want to start our Postgres database and the application. So we start our application, and it starts in a bit more than 2.6 seconds. And now we are going to optimize that. The first step I would recommend before upgrading to Spring Boot 3 is to upgrade to Java 21 because Spring Boot 2.7 supports Java 21. So maybe first upgrade the Java version, see if everything is okay, maybe update your dependencies, etc. So here we are upgrading the version in various places like SDK Manager, the Docker file, and our Maven build. Okay. Now that's done, we are going to upgrade to Spring Boot 3.3. So obviously, in your more complicated application, you may have more work than just updating the version in the pom.xml. I really advise to read the upgrade notes if you are doing that manually, or you use basically some automated tools like OpenRecipe, Spring Advisor, various tools to upgrade step by step your application to Spring Boot 3.3. We are also going to upgrade the JavaX package to the Jakarta package because Spring Boot 3 and Spring Framework 6 are doing the switch from the old package to the new one. It's painful, but it's not really our fault, so we do our best. And yeah, that's it. Spring Boot 3, especially Spring Boot 3.3, is really an enabler for optimization and efficiency features. So with Spring Boot 3.3, for example, we have virtual threads available, allowing you to scale better with the regular traditional Spring MVC Tomcat stack. And that will allow to use, instead of OS threads that consume a certain amount of CPU and memory, it will create lighter threads that will allow to scale better. And this is a flag like that allows to enable that as of Spring Boot 3.2. Since our goal is to optimize a bit the startup, and since personally I don't really like to upgrade the schema of my database during each startup, I'm going to remove that from Spring Boot and do that externally. So here I'm using this kind of convention on Docker side in order to automatically run my database script at startup. There is also various ways to do that. I'm also doing that because I have mentioned that with CDS, you may have early database interaction, and we want to minimize that, so that's also a way to work around that. Finally, and this is totally optional, so you can enable CDS optimization without enabling Spring AOT. Spring ahead of time optimization can be enabled on the JVM, so with Gradle it's just a plugin to enable. Here it's a bit more verbose with Maven. So we enable this process AOT thing. And we also set the BP Spring AOT enables variable to enable the Buildpacks support for Spring AOT activation. But that's optional. And be aware that AOT optimization are specific for a specific Spring profile. So you may have to add additional configuration to say I want to activate my specific profile. CDS, with basically Buildpacks is just a flag to enable BPJVM CDS enabled. You can also do things manually with Dockerfile or other things. You are not blocked. But with Buildpacks, this is just a flag. And I'm going to do a small modification of my configuration to make the dialect used by Spring Data JDBC explicit in order to, again, avoid early database interaction. And I think that's the best practice because that will allow your Spring Boot application to start without contacting the database. So it can help. We have documented most of the early database interaction that can happen by default and what kind of configuration you need to do in order to prevent that. So Spring Lifecycle Smoke Test is a project where we test and document crack and CDS supports. And if you go on this project, you will see configuration guidance for Spring Data GPA, JDBC, MongoDB, etc. for the few configurations that you have to set in order to avoid early database interaction. The support we provide on Tanzu Platform, you don't have to do that because we take care about automatically not requiring any customization. So this is an example of added value that we provide at Tanzu Platform level, and more features are coming. Last optimization, this is a teeny one, but with a big effect. WebJars is a technology that is used by the JVM ecosystem to use JavaScript and CSS frameworks as Maven dependencies. Not everybody like that, but it's available and widely used. The former version of WebJars, WebJars Locator Lights, was doing, and not Spring fault, it's not really our fault, but it was doing a crazy class path scanning at the startup, super slow, super inefficient, horrible. With Spring Boot 3.4 and Spring Framework 6.2, we are introducing the support for WebJars Locator Lights. We have been collaborating with the WebJars team on that, with Dev Sayer, myself, and the WebJars team, in order to improve the efficiency and remove totally the class path scanning at startup. And this is a flame graph that we had with the former version. So this efficiency issue has been found by the Spring community, and we have been able to totally remove this crazy class path scanning done by WebJars at the beginning. And now it's all by convention, super smooth. So let's see with all those optimizations what kind of efficiency we have. We build our application with Maven boot build image. We are using Buildpack to automatically perform the training run. We have enabled virtual threads, etc. Okay, so CDS optimization, the training run, everything is done automatically. I get my self-contained optimized container, and now we are going to start it and compare to previously. And now our application, our Petclinic application is starting in 1 second, which is pretty good. So here we see the various steps of optimization that we have done and the effect on the startup time. You can see that we start from Spring Boot 2.7, Java 8. We upgrade to Spring Boot 3.3, not a big difference. It's just an enabler for efficiency features. And then we enable the automatic unpack, virtual threads, Spring AOT, CDS. And here you can see we have a 42% decrease of startup time. And if you are using WebJars and upgrading to Spring Boot 3.4 and WebJars Locator Lite, you even get 70% of decrease, which is pretty good, without that much constraints. In terms of memory consumption, you can see that both Spring AOT and CDS allow to reduce the memory consumption after startup, giving you more memory for the heap of your application. So the gain are pretty good, not crazy, but I think it's, again, not a small, there is not a lot of constraints, so let's take it. And we are also going to check the performances. So there is a tool called OA that I really like. Here we are benchmarking our applications. You can see that we are warming up the application. So performances are increasing as we bench that. And as a second step, when the JVM is hot, we are going to do a second benchmark in order to get the real figures in terms of throughput, latency. And here we have a meaningful data point that we can use to compare performance. Same, we are going to show with each step the gains in terms of performances. So here I'm measuring the throughput on a 2 CPU and 2 GB of RAM machine. And you can see that Java 21 virtual threads are really allowing some improvement. Of course, it depends on your project. I don't claim that that will be the case on all projects, especially for virtual threads, where there is still some pin thread issues that may be fixed in, I think, potentially Java 25 next year. But it's already pretty interesting to leverage. And if we zoom on virtual threads, you can see that with a lot of resources, it provides some gains, sometimes, not always. But when you have very few resources, if you are running Spring Boot on a very cheap one virtual CPU, 1 gigabyte of RAM, it makes a huge difference because, I guess, each thread, so we have one thread per request, and the fact that we have much smaller footprint for one thread means that we have a much smaller footprint for one request, and it scales much, much better with limited resources. So I think this is interesting, especially if in the future we reduce this thread pinning issue. I think that's promising for the regular Spring MVC Tomcat stack. So Spring Boot 3.3, Java 21, and virtual thread and CDS allow you to use smaller and cheaper instances with better performance, with not that much constraints. It's much easier to leverage than native, for example. And it's not the end of the story. So the Spring team is collaborating with the Java Platform team on Project Leyden, which is a kind of successor of Project Leyden. In fact, the Java Platform team found that CDS was a super good fit with Spring Boot while working on Project Leyden, and they reached us, and now we collaborate very closely. So Project Leyden will bring even faster startup. So we are at 2x, and we could end up at 4x, but depends to be seen. So on my powerful machine, I don't claim this is the figures in the cloud, but on my Mac, I'm able to start with Spring Boot CDS support and Project Leyden early access builds. This Petclinic in less than 300 milliseconds. It's not native, okay? It's a regular JVM. It will also bring smaller containers because with Project Leyden, we can remove the CDS archive of the JDK, just keeping the one for the application, so the container gets smaller. And it will introduce what I call AOT warmup, which is basically a faster warmup. Yeah, we are out of time. Thank you for your attention, and yeah, thanks. Do you have time for a question? I'm not sure.
Yeah, if there are any questions, let me know.
Questions?
Yeah. Any questions? There must be some. That was a great talk.
Okay, feel free to come to talk with me if you are you want more detail.
Any
Bye.
other questions? Nothing? All right. Good job then. Yeah.
Thanks.
Thanks.